Hello everyone, this is Mariko, your host for the session. And today we would like to dive into the fascinating world of quantum transformation. And don't worry, I myself am no expert in this field, but I'm really excited to learn about how this new technology would be the next game changer in our society. So today we are welcoming a special guest, Matt Terabe. He is one of the world's leading experts in this field of quantum computers and how it's applied to business. He's actually the one who started this quantum transformation project. And previously, quantum computing was only studied in the field of maybe academia or maybe in research institutes or in science fiction. But Matt was one of the first to bring the concept of quantum to the business field. So for instance, he and Tohoku University conducted the world's first demonstration experiments using quantum computers to solve traffic jams in Thailand and to optimize routes for automated guided vehicles in factories. So now without further ado, let's welcome Matt to the stage. Hi, Matt.
Hi, Mariko. Nice to meet you too. Thank you for having me on such a wonderful stage today.
Yeah, my pleasure. And we're really excited to learn about quantum computing from you today. So first, could you tell us a little bit about this quantum transformation project that you've been working on?
Sure. Great to hear that you are all interested in quantum transformation. See, the world has progressed from analog to digital. From now on, quantum technology, which had previously only appeared in science fiction novels and movies and academic world, will be the next game changer. I've named this social transformation quantum transformation, and I'm currently promoting this quantum transformation project as a pioneer.
Okay, that's really interesting. So my first question is, what exactly is this quantum technology that you're working with?
Yeah, thanks for asking. I prepared a video about quantum computing, which is one of the most important quantum technologies. Let's take a look.
Quantum computers are expected to bring about the first social change since the digital revolution to drastically change the world once again. Let me explain about the optimization areas among them, where the implementation into the society is considered to progress quickly. Today, the digital computers we use calculate in a unit called bit. This is a unit to represent one digit of a binary number, and it will be either 0 or 1. Digital computers use semiconductors which conduct or do not conduct electricity to get either 0 or 1 by turning electricity on and off. Quantum in quantum computers is a general term for atoms, electrons, neutrons, and protons that make up all matters. Quantum computers proceed with calculations in a unit called qubit based on the mysterious physical phenomenon, quantum mechanics, that occurs in this tiny world. Quantum mechanics can create a situation where a qubit can have both 0 and 2 value at the same time, which is a difficult concept for us to understand. What happens by this is that if you try to find an answer from the combinations that 3 bits, 3-digit, can create with a digital computer, you need to calculate up to 8 times. However, a quantum computer searches for the optimal solution from all 8 combinations at the same time, while each qubit holds 0 and 1. In other words, in 3-bit, 3-digit calculation, a quantum computer searches for a solution from 8 to cube different options at the same time. But if you are talking about a 30-bit or 30-digit calculation, you will need to search for a solution from 2 to the 30th power, meaning approximately 2 billion options at the same time. Therefore, a drastic speed increase can be expected by using a quantum computer. By this ultra-high-speed calculation of the quantum computer, it is expected that calculations that were not possible, even with a supercomputer up to now, can be made possible. Among the cases where validation experiments have already been conducted, quantum computers are expected to make a great contribution to solving the social problem of eliminating traffic congestion. According to estimates by the Ministry of Land, Infrastructure, Transport and Tourism of Japan, traffic congestion causes an annual economic loss of 12 trillion yen within Japan alone. Although there are many different factors that cause traffic congestion, one of the major reasons is that cars are concentrated on a particular route. The current car navigation and smartphone navigation apps propose the shortest route first. Because people would choose the same route, this causes traffic congestion. When the navigation system detects congestion on the shortest route, it proposes the next shortest route. But this can also cause cars rushing to the same route, causing heavy traffic. Because we would prioritize ourselves arriving early, as a result, no one ends up arriving in their destinations early. As a solution to this problem, there is a method of implementing real-time car navigation with total optimization instead of individual optimization, by linking the car navigation systems of the cars in the city. When a flood of cars on a particular route is expected, you can prevent traffic congestions by dispersing traffic volume. Although the mileage per vehicle may be somewhat longer, dispersing the routes can increase the number of cars to reach the destination within a certain time, shortening the arrival time of each vehicle. However, it is said that such a society cannot be realized with conventional computers. This is because the calculation speed cannot keep up with the ever-changing traffic conditions in real time, even when supercomputers are used. Suppose you have two cars, where each can choose from 3 patterns of routes. If you are trying to verify the route where each one causes the least congestion, you will need to calculate a total of 9 route plans, 3 patterns times 3 patterns. Say you have 10 cars. The number of route combinations will go up to about 60,000, and if it is 30 cars, you will have to test about 200 trillion ways. In order to achieve total optimization, the calculation of this scale must be repeated in real time to keep delivering the optimal route to the driver according to the ever-changing road conditions. This is difficult with the current computers. As explained earlier, quantum computers are expected to be capable of processing this amount of calculation at a speed close to real time and return the results to the driver. As described, current computers have performance limits, and due to these restrictions, various social and business issues remain unsolved. However, quantum computers have the potential to break through that limit, supplement the performance of current computers, and lead us to see the new horizons. From space to underground, the Quantum Transformation Project aims to enrich our world with quantum technology.
Okay, thank you so much for sharing the video. And I feel like I have a much better understanding about the technology behind quantum computing. And this new technology, seems to be just around the corner. But there is one more thing I would like to know. And so my understanding is that, reducing traffic jams is indeed a major social problem. But are there any other business fields that this technology could be applied? Maybe in a broader term?
Yeah, that's a great question. A quantum computer itself is just an ultra-high performance computer. The most important thing is thinking quantum computers not only as just a technology, but think how society will change with this technology. We have some great ideas in our quantum transformation project, and I've created the video, so check this out.
Quantum Transformation QX will revolutionize every scene of the society we live in. For example, the cities we live in. Initiatives for smart city, such as the spread of IoT and 5G, as well as the utilization of big data, have already begun by digital transformation, DX. But quantum technology will further evolve into the quantumized smart city, Traffic jams, packed trains, unexpected queues, and congestion will vanish from the cityscape. In the near future, a real-time control and navigation of 3D traffic system will be achieved, where thousands of air mobility will be available, including drones. This kind of future is what quantum computing is capable of. Quantum computing plays an active role in calculations that need to incorporate various structures of the city, as well as activities of people who live there, since they cannot be done with conventional computing due to the tremendous amount of processing. There will be no such thing as a traffic light that keeps the red light on forever, even when there is no vehicle coming. Rather than functioning to achieve individual optimization with predetermined patterns and rules, everything will be mutually coordinated in real time to achieve total optimization. Quantum computing could pick up and instantly calculate the effects on the city caused by your slightest little whimsical behavior and absorb them into the overall harmony of the city. As the 5G communication system continues to evolve to 6G and 7G, and the amount of data flowing exponentially increases continuously, quantum computing will keep advancing itself to handle the processing. QX is also essential for all of our sustainable growth. Renewable energy sources such as solar power and wind power are highly expected to be used in the field of climate change, especially carbon neutrality. However, the amount of power generated is greatly affected by the weather and climate, making it difficult to balance the power supply and demand, which hinders its spread to the general public. In the near future, along with advances in hydrogen technology and electricity storage technology, as well as the advancement of quantum computing, real-time energy demand control will be made possible to bring a society where the possibilities of natural energy sources can be maximized. Food waste problem has become a major social issue in developed countries. With QX's total optimization of supply and demand, a supply chain with zero food waste may be realized from farm to table. In the industrial field, production of smaller quantities in more variety of models will continue to progress. QX smartifies the factories that support this. It will instantly respond to changes that continue to occur in the factory every day, such as problems with manufacturing equipment, additional orders, and changes of the employees to achieve the highest production efficiency. QX also optimizes air, ocean, and ground transportation for logistics that deliver these products to us and reduces energy consumption. Computers are the foundation of a smart society. Due to the progress of data utilization in recent years, the number of data centers where computers are concentrated has increased remarkably, and the amount of power consumption also increased drastically. Here comes the quantum computers to play an active role again. Their energy consumption is much lower than the conventional computers. Although they cannot replace the conventional computers entirely, the power consumption can be suppressed by the quantum computers taking on some enormous volume of complex calculations such as AI. Not only does QX harmonize the society and protect the environment, but it also widely opens up our future. In the underground space, for example, QX is expected to be very effective in underground sequestration of CO2, as well as mining of underground resources. The underground world is a complex combination of gas, liquid, and various types of rocks and ground, changing its appearance like a living creature when a drill goes down. By excavating this safely and efficiently, QX contributes to having the CO2 fixed in the soil and extracting underground resources more effectively. With improving accuracy of geological structure analysis and strength level calculation, new ways of utilizing the underground space that has not been discovered will be promoted. The future of a vast underground city may not just be the science fiction anymore. QX will also bring an impact on space exploration. New materials created by quantum technology may be able to make cheaper and stronger spacecraft to travel in severe outer space environment. In addition, there is a large amount of junk called space debris floating in space, and its collision can cause a tragic accident. Understanding all the orbits of these debris objects and guiding the optimal orbits and routes can lead to a safe space journey. From space to underground, QX project tackles every transformation of the world. Quantumize, optimize, orchestrate the society.
Wow, that was amazing. And so, I understand that quantum will not only change our daily lives, but will greatly contribute to, lowering carbon and creating a better sustainable world for the future. And, I think that this is the kind of technology that we really need now and the kind of society that we need to be creating for our future.
Yeah, exactly. Our quantum transformation project, we've already started working on these concepts you saw in the video. For example, in preparation for the future of air mobility, we are demonstrating the use of quantum computers in a real-time 3D traffic control system to see if it's possible. In addition to this, we are planning to turn a huge, more than 600-acre smart city, North Hanoi, into a quantum sustainable city in the next 10 years.
So wow, you really are creating the future with quantum. So my next question is, where does Japan stand in this quantum transformation field?
Yeah, so Japan was actually the very first country to realize quantum bits and invent the quantum annealing algorithm, which is one of the most practical way of quantum software today. In terms of quantum technology, the US, Canada, and European countries are also very advanced. But, as I said, one of the most important things is not only the quantum computing technology, but how this technology is going to enrich our lives and the world. This business aspect is the part of that we will strongly be focusing on. I noticed that time is almost up. So again, thank you for joining us on this journey. And we really love everyone to join us to take on this challenge together.
So thank you so much for today, Matt. This was such an exciting and inspiring discussion that we had. And I really hope to work with you soon. So hey everyone, I hope you were all able to get a good understanding about quantum transformation. And I myself am already very excited to learn more about quantum transformation and be involved. So later today, I'm going to be talking with two more proponents of quantum transformation online. The first one is Professor Ozeki from Tohoku University. He is the leading researcher in the field of quantum computing applications in the world. And the second person I'll be talking to is Ms. Maëva. She is the chair of IEEE Quantum, which is the quantum subcommittee of IEEE, the world's largest technology standardization organization. So please stay tuned, and I will get back to you real soon. See you. Quantum Sky Project. Quantum computers will change the sky in 2030 something. The world is coming to a point where hundreds and thousands of flying cars, drones, and other air mobility vehicles will be flying over cities. However, it is difficult to achieve this with conventional computers. Why? Because it would be necessary to choose a safe and efficient route from numerous number of combinations, taking into account real-time changes in weather, radio waves, and other air mobility conditions. The traditional method can only optimize about 40 units simultaneously. The future-ready algorithm we have developed for the quantum computer era can optimize about 70 units simultaneously. We have confirmed that the quantum computer can improve the speed of small-scale problems by a factor of 10 or more. We expect that future optimization of hundreds of thousands of units will result in even greater efficiency and speed. In the near future, there will be a society in which air ambulance and emergency transportation will save more lives than conventional ground transportation alone. With ultra-high-speed optimization, we will be able to enjoy safer air traffic on a daily basis, changing the way we think about the distance we travel when commuting to and from work. In the 20th century, with the advent of passenger planes, our world became very small and countries became very close. In the 21st century, with the advent of air mobility, our cities will become a more spacious and comfortable society. We will construct a next-generation mobility logistics that will deliver the right amount of necessities only when it's needed. And we will be able to leave a sustainable society for children without waste in the future. So welcome back, everyone. I think we were all able to get a basic understanding of this quantum transformation project and the things that we've been working on so far. So up next, we would like to get some views from an academic profession. We would actually like to invite Dr. Ozeki to our stage. Dr. Ozeki is a pioneer in social implementation in the field of quantum annealing. So quantum computing actually has various fields of study, but his study, quantum annealing, specifically focuses on optimization. He is the leading expert in this field from the standpoint of both academia and startups. So Dr. Ozeki, if you're ready, please join us now.
Hi everyone, this is Masaaki Ozeki from Tohoku University. Yes.
Okay, thank you for joining us today. So in this session, we would like to learn about some of the studies that you've been working on and how you as an academic expert see this whole quantum transformation project and how you take part in it.
Okay. So the main appealing point of quantum computer is power saving and powerful computer performance, and but we don't really know that what it can do. So therefore, we are in a situation where we have to start research, application, and actively think about what we can use it for. So the first work for the application of the quantum annealing, so optimization, GWorld. So for example, with the Denso Corporation in Japan, which is a car supplier, a part supplier. So and they have many plants. So and they are making many car parts in France. So then they use some automated guided vehicles, so automatically driving system in France. So the automatically car carrying the many of the parts, car parts, and manufactured parts. So then in the front, very narrow and small area, but many automated guided vehicles carrying their manufactured car parts. So then we consider and formulate a new system with quantum annealing. So while optimizing movement of automated guided vehicles and for carrying many car parts, manufactured car parts. For example, let me see some movies, for example, like this. So you see on my screen, and for example, the bigger. So you see the movement of green points. So green points denote the movement of the AG-voice automated guided vehicles. So and you see the some blue circles. So the blue circle denotes the appearance of the traffic jam of the AG-voice. So and you see the some increase the size, increase the radius of the blue circles. So which denotes the degree of the traffic jam. So you see the heavy traffic jam in this plant. So but if we use quantum computers, so quantum annealing for optimizing the world, so like this, So you look at some difficult cumbersome equation, but no problem. So we formulate a new system, so sending the problems to the quantum computer, and we have always received the solution. So the solution makes smoother like this. So green points moves in front smoothly, and you look on this map. So the decreasing the degrees of traffic jams. So this is the first kind of the application of the quantum computer. So this is this is our recent study. So Renjiro Haba-san, who is a master student of our university, so he makes better systems. So you look the various type of the calls and the various type of the tasks are performed in these plans quickly. Yes, and the second one is like this. So with recruit lifestyles, so they have some website. So for booking the hotel. So then listing of the hotels you can access on the website. So then you choose which is better, which is excellent. So but list of the similar region or similar hotels, similar class of the hotels, or you avoid. So therefore we increase the diversity of the item list, hotel list. So then we optimize the item list, hotel list by use of the quantum computer. So then the rate of the click, rate of the booking hotels is increased. So therefore they have a business uplift. So the quantum computer is affect some business impact. The third one is like this. So we at Tohoku University suffered from the big earthquake 2011. So and always we are suffering from the earthquakes in Japan. So for example, this is one of the areas in Japan, Kochi City. So the Kochi City will be affected by the some tsunami attacks from after the big earthquakes. So then we have to consider the quick escape from the dangerous areas. So you see the blue points. So blue points moved from the maybe the right lower side to the left top side. So then you have to go across the rivers. So then you have to choose which bridges across the river is safer, safer. Yes. So then we have to consider some optimal choice to the bridges. So then we formulate these problems as a quantum computer solved problems. So then this is traditional car navigation system. So you input to the from the starting point to the destination point. You input some information to the car navigation system. So then you suffer from traffic jam, heavy traffic jam. So, but if you use some service with quantum computers, okay, without any difficult equation, just only access some sites driven by the quantum computer, so you can receive good information to escape quickly from the dangerous areas, even after the big earthquake, even after the tsunamis. So the quantum computer has many potentials to support our business or our service, some infrastructures to make our daily life is safer and better. So, and I have to say, this is an event in the USA. So, as a member of the Tohoku University, I would like to express my gratitude again to the USA for their rescue operations, Tomodachi. So, during the big earthquake of 2011, thank you very much.
Okay, thank you, Professor Ozeki. Thank you so much for your explanation. I think we were all able to understand that quantum computing is actually working from both academia and business point of view, and actually has so many ongoing projects even for now. So thank you for that. So now I would like to move on to some Q&A. So my first question is, why is quantum computing attracting so much attention now?
Okay, maybe I think the issue of energy is crucial. So rapidly emerging in several countries around the world. So and it is yes. And we have high hopes for the power saving and high performance quantum computers. So the truth is that the world is looking for some adventure in the search for new technology. So maybe the most people know well. So artificial intelligence or deep learning, some techniques of the machine learning, but maybe the most of people want to learn a new technology. So that is a quantum competition. So I think the appealing point of quantum mechanics was perfect for that adventure.
Thank you. So my next question is, how will our lives change with quantum in maybe 5 or 10 years? It feels like, quantum computing is as a study that could maybe go on for 30 or 40 years. So is it going to affect our daily lives in the near future?
Okay, maybe it will be a world where there is no waiting time. Yes. So maybe in a short time, so shopping and transportation will become more efficient and efficient. For example, the applications of the quantum annealing I showed. So, and from a longer term perspective, it will accelerate the speed of research and development of medical development and medicines and treatments, and by accelerating the speed of finding out what kind of arrangement of atoms and molecules is best. So, which is which is in research of medicines, and it will speed up the discovery of excellent medical care. So, this is a long-term perspective future by quantum computation.
So my third question is, so I don't come from a quantum computing academia background. So a lot of these technical words seem a little bit difficult. So I would like to know if there are any differences between some of the technology that we hear now, such as artificial intelligence or deep learning.
Oh, yes. Artificial intelligence is a technology that predicts what will happen next. So, because this is what has happened so far. So, on the other hand, quantum computers or quantum annealing are technologies for designing the future. So, something new and think about what result it will lead to, which is not an extension of something else. So, therefore, yes, this is a point, big difference point between the artificial intelligence and quantum computers. So quantum computer makes a future.
Thank you. So my fourth question is, why should we take on this quantum computing technology and utilize this through our business now?
I think it's a new feeling for the people. So there is a value on experiencing some unknown of quantum mechanics itself. So quantum mechanics has some mysterious value, mysterious points. So, but it is hard to understand the quantum mechanics, of course. But quantum mechanics produce results that are completely different from our common sense. So, therefore, in order to learn and feel the new common sense, so we have to jump into the world of quantum mechanics. That's the value.
Okay. Thank you. Okay, so if we were to adapt quantum computing to our business now, what would be the first thing we should work on?
Yes. Please watch my YouTube movie. It's subtitled in English. Of course, I speak usually Japanese, but yes, it's subtitled with English. So it's a good way to learn how to do quantum annealing for beginners and applications of the for business. And because I gave a very long lecture while exercising the programming and while answering all the questions from the people. Yes. So therefore, please watch my YouTube.
Okay, thank you. And maybe we could contact you if we have any questions. Thank you so much for joining us today all the way from Japan. I think we were all able to understand how the academia world is involved in this quantum computing project and how there are ongoing real projects already that's been happening, which was really exciting to hear. So thank you so much. And can we get some last message for our audience?
Okay, thank you very much from Japan. The advent of quantum computers is a valuable turning point for humanity, I think. So it is a good opportunity to embark on this challenge. So let's take on this challenge together. Thank you.
Okay, so in our next session, we'll be inviting Maëva. And Maëva Ghonda is a scientist born in Kinshasa. It's the great capital city of the Democratic Republic of Congo. And her passion for quantum computing ignited while working as Joint Quantum Institute scholar. And she is the editor-in-chief of the IEEE Quantum Computing newsletter, the host for the Quantum AI series podcast, and the chair of the Quantum AI Institute. And as a research scientist, her work is centered on technological innovations. For example, quantum computing, artificial intelligence, and machine learning. And to tackle challenges in pharma and healthcare, as well as climate change. So that's all. I invite Maëva to the stage.
Thank you so much, Mariko. Thank you so much for having me.
Yeah, thank you for joining us. So could you first tell us your passion behind this whole quantum computing project?
Sure. So quantum computing I'm very passionate about this space just because of the potential future for quantum computing is very promising. And these special purpose machines truly have the potential to transform many sectors of great importance, including communications, manufacturing, and national defense. And that's a key reason why it's garnering tremendous attention worldwide. It has immense strategic value, particularly as it relates to national security and the economic security of many nations. And to prepare for impact, it's truly important for public and private organizations, as well as government across the globe, to work together to help research and accelerate the development of quantum innovations in order to create real value. As an example, the state of New York now estimates that by the end of this decade, the adoption of quantum computing by local companies could increase the state's GDP by a stunning $332 billion.
And Maëva is also the founder and chair of the flagship Quantum Computing Education Certificate Program for Workforce Development and the creator and executive producer of the live Quantum Computing Executive Interview Series. Both quantum computing programs are sponsored by IEEE Quantum and the IEEE Standards Association.
Thank you so much for bringing up these excellent programs, Mariko. So given the rapid development in quantum computing in recent years, we formed strategic collaboration with different industry partners in order to help inform and educate basically the global population for free. We make sure the content is affordable and really anyone can join that is interested in transitioning to quantum computing. So there are two key programs, as you mentioned. the Quantum Computing Education Series, it's actually a certificate program. So if you attend a course, you actually earn a certificate for participating. And for engineers that require continuing education credits for their licenses, we also offer continuing education units, continuing education credits. And the Quantum Executive Series, those events are really innovation center talks for senior level leaders. And these include the summits that I host, symposiums, and conferences. And the mission of these series is to foster collaboration among leaders in quantum with thought-provoking intellectual discussions. And a key focus of these events is to bring in leaders that can help inform, anyone with interest in quantum, really, with real use cases that they could go ahead and implement in their strategy now. And ultimately, my aim is to produce robust programming throughout the entire year. I have about 30 planned for this year, and this combines, this is a combination of the quantum computing classes as well as the executive forums. And really, these are free to anyone. So I really encourage anyone with interest in quantum that wants to transition into this space to register for free at IEEE Quantum, because they really provide extraordinary values. And again, we offer free certificates to people attending. And the feedback that I've gotten is that it has true marketability, employability value for the learners that do come and attend our events.
Okay, thank you. So I think this program is great for, some of us who are, interested in learning about quantum, but kind of, don't know where to start. I think that's where most of us are right now. So yeah, thanks for sharing that.
Yeah, and what you bring in is extremely important because it caters to the entry level individual that wants to transition, as well as the PhDs. We have some higher level courses that are taught by, they're all industry practitioners, but they're a lot more complex, and you do need a certain level of understanding to take those. But I intentionally didn't want to separate entry, the early learners from the more experienced ones, because I want people to come on this site and see what's next and look at what could be. Because I feel that when you don't do that, when you keep, entry level and more advanced content separate, you don't always know what the potential is. Because I think it's important to see someone that looks just like you, that's building quantum computing systems. If another human can do it, hey, why not you? So I think it's encouraging to have, like I said, that's why I think it's important to have the entry level content as well as the more advanced on the same site, because you can look at what's next, what you could become if that is your interest.
That's true. I come from a poli-sci background. I don't have any experience or knowledge around quantum computing, but I think that would be very helpful. Thanks. So is this program all online, or are there any opportunities for us to maybe see the real quantum computing systems on site maybe, or?
Yeah, that's a great question. I was hoping to have in-person events by last year, but COVID had other plans for me and the entire world. So I'm hoping to have my first event by the end of the year. Yes, the plan is to actually have learners. I don't use the word students because I want to make sure that we're inclusive of all age groups. This is really a workforce development program, regardless of age. So it's really, the goal is to bring together learners for the education program and, sit in class together and network and learn from each other in person, and meet the instructors. And the same goes for the executive forums. I am planning my first one this year, hopefully in DC in the next several months here. But as long as these variants behave, I'm excited to finally meet many of you in person soon.
Okay, thanks. So, I'm kind of wondering your passion around this whole education part of the quantum computing part. So you mentioned about your passion towards, quantum computing itself, but do you have any like passion behind kind of educating everyone around you? I think this is the whole thing that you've been working on.
Yes, as a person of color of African descent, education is freedom. I believe that education opens doors. And part of the reason why I'm doing this is because I don't really see many people that look like me. I don't see a lot of Black women in quantum. And I recognize that a key reason why is often, for underrepresented groups, we don't always have the same opportunities. That it was partly that frustration that drove me investing so much of my time in educating and making sure it's free, because I recognize if it's not going to be a level playing field. We have to be realistic, and I can't just hope and wait someone else does it. But that was really the driving force. I mean, it's amazing. I meet people from all over the world like you in quantum, but I don't see as, many, Black girls like me.
I think you have you have a really, great point there. And, your activities, I have so much respect. And especially, my image of quantum computing before this session was, kind of all taken in like, laboratories, or, you would only see them in like, I guess, like very high tech companies, but your point gave me the understanding of, it's actually there for you to learn for free, which is really exciting. So thank you for sharing that.
Absolutely. And the key point is companies need non-scientists and non-technical people also. Quantum computing companies need administrators, accountants, but it's important, even if you're not necessarily a scientist, to have a certain level of understanding. And that's why I say it's good to have entry-level content that's not necessarily super complicated for people that want, just baseline information too, that won't necessarily be building the quantum computers.
Okay, yeah, that's great. Thanks. Okay, Maëva, thank you so much for coming in today and, telling us about your passion behind this whole education part of quantum computing. That was really interesting and exciting to hear about that. So I'll be sure to check out your IEEE program and try it out. Thanks.
Thank you so very much. Thank you for inviting me. I'm truly, really, it's a great pleasure to work with the whole team at Sumitomo. But I do want to emphasize to everyone, please, if you are interested in quantum, come to the IEEE Quantum program page. We're offering free courses and free conferences. And you can join from anywhere in the world because the great majority are online. We have over 30 already that you can join at a moment's notice on demand 24/7. Whatever your discipline, whatever your background, we have something for you, because we do cater to individuals from, with no quantum experience, and also for the PhD level. We also have PhD level content for individuals that want more advanced technical information. We also have my executive series where we provide, we share real life use cases so that senior leaders can be informed to help develop their quantum computing strategies. Thank you again. It was a great pleasure joining you all today.
Thank you.
it's alright. We'll go find the answer to shine your day brighter. We don't stop, we won't give up. Come with us.